All right, chapter 12-4 is going to be volume of pyramids, cones, and spheres. So far we have done perimeter of shapes, 2D shapes, which you just add up the outside edges. We've done area of 2D shapes, which our jump start today kind of went over that or reviewed that a little bit. Today, we're going to be moving into 3D images. And so we're going to be finding the volume. And what volume means is how much, if you think about it like a cup or a cube, if you were to pour water or sand or something into an object, how much can it hold? So the volume is kind of the total area of the whole inside, not just a flat 2D image, but of a 3D image. So if you think of a cup or a bowl or a cube or something that you're filling with water, or if you were to think like a big corn bin grain, right? So that's a big cylinder. How much corn could it hold? That's what volume is, okay? All right, so we need some equations here. And after you get the equations, the actual work of it, it's just kind of that plug and chug. And you guys should be very good at that. And I'll walk through how to do it in your calculators. And everybody, thank you, Mrs. Hain. Everybody should have a good calculator. So whether it's your own or one of mine, you got to have one of the good ones that has the pi symbol on it. Okay. All right. So volume of a pyramid. Now this is the only one that gets a little tricky. And this is where we introduce the capital B to you. So volume of a pyramid is V equals 1/3 capital B H. Okay. Capital B H. And the reason this is a little tricky is because you've got pyramids that can be different shapes. So if you look at the example here of number 1 and number 4, these are both considered pyramids because they both rise up to a point at the top, okay? But if you look at the base of number 1's pyramid, it's a triangle. And if you look at the base of number 4's pyramid, it's a parallelogram, which is why we reviewed area of a triangle and a parallelogram today in your jump start. So with this one, the capital B here, okay, the capital B equals, whoops, the area of the base as a 2D image. Okay, so you kind of have to detach your brain for a second of the pyramid, okay, which you don't, but kind of what it means is you kind of forget that it's a 2D image for a second, okay, and you just look at this flat triangle. And then, okay, the formula for this, okay, so the formula for B, for capital B, depends on the shape of the base. And that's why I have to leave it as a capital B. I can't tell you what the formula is going to be because I don't know if the base of the pyramid is a triangle or a parallelogram. And like we did on our jump start, like we reviewed on our jump start, if it is a triangle at the base, right? If it's a triangle at the base, like number 1, then the capital B is going to be 1/2 base times height because that's what the area of a flat 2D triangle is. For number 4, it's a parallelogram, so that capital B is going to be base times height. Okay, so you have to, in order to plug what capital B is, you've got to determine which base shape is it, and then use the area of that base or of that shape. Make sense? All right, so let's do number 1. Okay, so first of all, oh, wait a minute. Let me go ahead and give you the other formulas. I got kind of sidetracked on the base of these pyramids. For cones, we need volume equals 1/3 pi times radius squared times height. Now, notice that the volume of a pyramid is 1/3 the area of the base times height. Cone is 1/3 the area of the base which is area of a circle, times height. So really, this could be written as V equals 1/3 capital BH, but that requires you to remember that the area of a circle is pi r squared. Does that make sense? So the capital B is the area of the base, whether that is a triangle, a parallelogram, a circle, okay? But for cone, because the only option for the base is a circle, we just write it as pi r squared times height. Okay, we don't typically use the capital B in a cone because there's only one option for the base. In pyramids, we have to use the capital B because there's two different options for the base. But for cone, we just use pi r squared in place of the B because that is the area of a circle. And then last, we've got the formula for a volume of a sphere. And that is V equals 4/3 times pi times radius cubed. And we've not really seen a cubed yet, but that is the formula for volume of a sphere. Okay. All right, so let's put these into action. And again, these are just plug and chug. Once you have the formulas, you guys are good at plugging in numbers into formulas. And that's really all this part is. So if we look at number 1, we're going to be using this formula because it's a pyramid. Okay, so we're going to be using V equals 1/3 times the base times the height, right? This is going to be the base times the height. And if it helps you to write the formula above the parentheses so you know what you're plugging into each parenthesis, that's totally fine. All right, so the capital B here, we've got to decide, is our base a triangle and or a parallelogram? And we've already kind of outlined it, it's a triangle. So if just for a second you detach yourself from the 3D part of this, which means covering up, right? Kind of covering up this right now for right now, and just look at the actual 2D of the right triangle, base times height. Well, our formula is 1/2 base times height. Our base right here is 12. And our height right there is 12. Okay, that is the capital B, which I didn't really leave myself much room there, did I? Capital 1/2 times base times height, right? That's the formula for area of our triangle. And then it's times height of the act. Now we're back to 3D. Now it's times the height of the whole 3D image, which is right here with numbers with the 17 inches. Okay. Now what so far, what we've plugged in, which of these numbers carries with it the unit, which would be inches in this case? What do you guys think? Does the 1/3 part of the equation, it doesn't have inches. The 1/2 part of the equation doesn't have inches. So it would be 12 inches, 12 inches, and 17 inches. Okay, that's going to become important here in a minute when we write our answer. Now, punching it in your calculator, okay? The button sequences that you're going to use is 1 divided by 3 equals, and then leave it, don't clear it. Okay, that's going to get you your 1/3 basically in an easy way. If your calculator that you're comfortable with, you can punch in fractions, you can, but if you're not comfortable with it, make it easy. 1 divided by 3 equals, and then hit the times button without clearing it. Now, what would I put in the calculator to make 1/2 really easy to input? 0.5, right? Times 12 times 12 times 17 equals. That's going to be your button sequence. Okay, so everybody do that. 1 divided by 3, hit the equals button. Don't clear it, hit times. 0.5 times 12 times 12 times 17 equals. Somebody tell me what you got? 408. Did everybody get 408? I want to make sure everybody's got the sequence in. All right, how are we going to label this? Cubed. Why cubed? Because there's 1, 2, 3 inches in our formula, which means inch times inch times inch is inches cubed. And that would be your final answer. Yes, and I will say this part right here that I'm about to highlight, this was just for me to show you how to put it in your calculator. This is not part of the work you're going to show me. Do not write that down. That's just showing you the calculator punches. Okay. All right. Which means, let me erase that real quick because that's really. How did I get what? How did I get what?
He got 12. He got 1,000.
Well, punch it in. I want you to get it right. So punch it in again. Oh, give him his calculator back. I want you to punch in 1 divided by, clear it out. 1 divided by 3 equals, that's your 1/3, times 0.5. There you go. You got to hit times. Yeah, gotcha. And basically what the 1 divided by 3 equals is, it's putting 1/3 in your calculator. And if you have, and you're comfortable with your calculator that uses fractions, there's actually a fraction button on these calculators, but sometimes it can get a little tricky to use. And rather than making it harder, to me, I think it's just easier to do it as a 1 divided by 3 equals, and then go ahead and times, multiply everything else out. Okay. All right. So now let's move to our cone. So our equation here is volume equals 1/3 times pi times r squared. So I'm going to leave this, that's going to be my r squared times my h. Okay, that's what I'm going to plug in there. So in for the r squared, what is my radius? Blake? Yeah, because notice they give you all the way across. So they give you diameter. We need radius, so we have to cut that in half. So it is 1.5 squared. And then the height of our whole 3D image. Good, 3. Now, again, when you're putting this in your calculator, yes, there is a squared button on your calculator. And if you're comfortable using it, go for it. If you're not, how could I put 1.5 squared in my calculator? Yeah, 1.5 times, 1.5. So you can replace 1.5 squared with 1.5 times 1.5. And you don't have to worry about the caret and getting up in the squared spot. And okay, again, if you're not comfortable with the calculator, there's always an easier way to do it. All right, so put it in your calculator. 1 divided by 3 equals, helps if I punch in the right numbers, times pi times, and I'm just going to put 1.5 times 1.5. That takes care of my 1.5 squared. 3 equals, and let's see, who haven't I heard from yet today? Gabby, what'd you get? Okay, so times 3, because you have to do times the height, equals 7.6. Okay, so we got a decimal. So where should we look to see how far we should round it? Yes, it says right here, round to the nearest tenth. So Gabby, how would I round that? Well, no, I don't want to convert it to a percent. I just want to round 0.06 to the 10th. So if I get 0.06, but I want to round to the 10th, the 6 tells me to do what to the 0? Yeah, it'd round up to a 1. Make sense? Did everybody get that on their calculator? I want to make sure we're putting it in right. Yes.
I got 22.2.
Okay, so clear it and let's do it together. 1 divided by 3 equals times, without clearing it, hit the times button, pi times 1.5 times 1.5 times 3. Did you get it? Will you check his inputs? How am I going to label this? Yards, squared or cubed? Well, how many yards do I have in my equation? 1.5 yards times 1.5 yards times 3 yards. That's 3. So it would be cubed. However many yards numbers you have in your problem is how many yards you're going to have in your answer. Yes.
Sorry, but wouldn't it have to be cubed no matter what? Because let's say like 3D.
All the volume ones are.
Yeah.
But I always try to show you how to find it so that if you forget, you can always go back to the basics of just how many yards do you have in your problem. Yeah. Area is always going to be squared, volume is going to be cubed. Yeah. What was the other one we had cubed? Didn't we have one during chapter 11 that was cubed? Now I don't remember. I don't know. I'll have to go back and look, but you can always find it by looking to see how many you have in your problem. All right, last one is volume of a sphere. Okay, so we're going to go volume equals 4/3 times pi times radius cubed. Radius cubed. So we need to look at this kind of detached from the 3D image and say, what's the radius of this circle? 7, because it's just halfway across. Now, again, you can either, in your calculator, you can either put 7 times 7 times 7, or if you know how to use your calculator, you can do 7 and then like the little caret and the 3 and hit equals. I don't care which way you do it, you're going to get the exact same answer either way. Okay, if you're not familiar with the calculator, I kind of like to go back to the basics. So it kind of helps a little bit. All right, everybody put it in. 4 divided by 3 equals. Don't clear it. Hit times. Pi times, and then 7 times 7 times 7 and equals. And Sophia, when you're done, will you tell me what you got? Okay, 0.75. So we're going to round, which gives us what? Good. And let's see, who else haven't I? Eli, how am I going to label this?
Feet.
How many feet?
Yeah.
Yeah, and again, the pi doesn't have a feet, the 4.3 doesn't have a feet, but all 3 7s have a feet, right? 3 feet times 3, or 7 feet times 7 feet times 7 feet is feet cubed. Yes,
Oh, never mind.
okay.
I was thinking on because I thought it wasn't cubed. I had it squared instead of cubed, and that's why I got.
I gotcha. Are we good there? Make sure you have these formulas written on your notes. You will need them. All right, last one we're going to do is number 4, and that's because it's a pyramid with a parallelogram as a base. Okay, so we're going to do volume equals 1/3 times capital B times H. So we're going to plug in, okay, capital B is the area of the flat bottom of the pyramid. Well, the shape of the flat bottom of the pyramid here is a rectangle, which means it's base times height. So for our capital B, it's going to be 11 times 38, and then times the height of the actual pyramid itself, which is 10. Okay, so for pyramids, you need to find the area of the base shape, and it can be a triangle or it can be a parallelogram. Okay, now in your calculators, again, it's 1 divided by 3 equals. Don't clear it, hit times. 11 times 38 times 10. And Damien, when you get it. And that's rounded. Good. And then Colton, how am I going to label this one? Meters cubed, because it's 11 meters times 38 meters times 10 meters, which is 3. And there's your answer. So if it's a pyramid, determine your capital B, whether it's the area of a triangle or area of a parallelogram. Okay. For the other two, just plug it right into the equation without any changes. All right. All right, on your homework, and I'll tell you guys this again when you have it, but this is for the online people, you can cross out and not do number 5, number 6, and number 7. Okay? And email me if you have any questions.